Hi guys, I'm Paul. This video is going to provide you with the knowledge on how to implement a shared pointer. Now, starting with why. Why do you care about the shared pointer? Well, you care about the shared pointer because you don't want a mess that stems out of unmanaged shared ownership. What is that? Let's say that there is some dynamically allocated resource. Let's say that it is a DirectX buffer, okay? And there is multiple objects that, for whatever reason, hold reference to it. They use this buffer, okay? Now, those objects, they have varying lifetimes, which basically means that we don't really know which one dies last and which one should erase, deallocate, delete this buffer, okay? We don't know that. And when we don't know that, there might be some problems, because either we pick at random, okay, this one will delete it. And if we do this, well, there will be a couple of problems, because if it's so, well, we might be wrong, and some other object will try to use the resource after it has been deleted. It will be a dangling pointer problem, it will be a bug and undefined behavior, basically. There is another possibility. Two objects will try to delete this resource, and that's double deletion, and that's again undefined behavior. And the worst of all, we might say, well, I don't know which one should delete it, I won't delete it, it's a memory leak, and it's also not very great. So what do? Are we helpless against it? Not really. You see, in C++11, shared pointer has been introduced, and shared pointer solves exactly those problems. Shared pointer comes in and says, okay guys, listen, I'm gonna worry about that for you, okay? What happens is that shared pointer, it can be copied, okay? And every time a shared pointer is copied, the internal counter of the shared pointer increments. And when a shared pointer gets destroyed, okay, this same counter gets decremented. And when the counter reaches 0, what happens is that the resource gets deallocated. So that is a really smart way if you think about it. It's a really simple way, but also an effective one. And today we are going to do just that. It's more complex than you think. Now, let's start implementation. Here, as you can see, we have already created a shared pointer class, template class, and now we'll create a control block. Now, what's a control block? I didn't mention that. Well, control block is the actual thing that manages the lifetime of the resource and counts the references. It's an internal class. It's also a template class. It stores a pointer, as I said, and it stores a reference count. Now, there's a couple of functions here. We can write this as private, although classes are private by default, right? So now, what we need to write here? Well, okay, so let's start. First of all, we need some kind of constructors, right? So the simplest constructor that comes to mind will just be one that takes in a pointer. And it allocates it, well, it actually assigns it like that. Now, obviously ref count will be initialized with 1, since when we create something, it's only one reference to it, I guess. So we don't have to initialize it in constructor anymore. And then there is the second, more interesting constructor, which is a template constructor that is used for perfect forwarding of parameters. If you want to construct the resource in control block, let's say. So instead of assigning it, we'll just create it and assign it in a constructor. And we'll do it like that. Control block. It's the same pattern that we have used in the unique pointer video. It's a recurring pattern in C++ really. Now it looks okay to me. Now there is a couple of functions needed. First, most important function really is the one that returns a reference count. So let's make it. Let's write it, right? Let's call it use count. It's a const function and it returns a ref count. Lovely. Now there's a second function needed, one that returns a resource, and you will see shortly why is that. It's also a const, since this function doesn't change the resource, and it just returns a resource. Okay. There are last two functions. There's in our public API, one will be needed for incrementation, and there's one for decrementation of the counter, right? So increment, that's fairly simple. And then a bit more complex, decrement. Let's go. It decrements and then it checks if ref count is equal to 0. You can obviously write it in a simpler way, something like that. Like that, but this is not readable, so we'll just stick to ref count equals 0. And if it's true, we'll delete the resource. So there is no pointer pointing to a resource. We should delete it, right? This is what I was talking about. And then we delete the control block too, because control block will also be most likely, like 99% of times, dynamically allocated. Actually, if it's not, this is a mistake. This should be dynamically allocated. Now we have created a perfectly operational control block. Now let's go to implementing shared pointer. Shared pointer also holds a resource pointer, and it holds, as I said, a control block pointer. Let's call it a CB, and let's initialize it to null pointers, both resource and CB. Okay, lovely. Now this is private, obviously. We will need a couple constructors now. Let's start with public interface. Now I said the public interface is begin with constructors. Now let's make an explicit constructor that takes in a pointer of type T pointer and assigns it. And same constructor will also construct a new control block. Now, another constructor that we must provide is a little more interesting. Is a constructor that takes in already created control block, already dynamically allocated control block. This should probably be somehow enforced. I should think about it really. It takes in dynamically allocated control block, pointer to it, and assigns it, and then uses get to retrieve a resource from it. So let's do this. It will also be explicit, obviously. Explicit shared pointer takes in a control block pointer, CB. And what it does is that we assign CB inside a class, inside the constructor, and if CB is not equal, is true, right? So it isn't null, it is not null pointer, we will assign the resource with get value. Now, perfect. Now we will be implementing copy constructor and copy assignment operator. This is where the magic happens. Let's take a look. So shared pointer takes in const reference to another shared pointer, and resource gets assigned other resource, and control block gets assigned other control block. But now, in the body of the constructor, we will call CB. Well, actually, first we will check if CB is not a null pointer, and if it isn't, we will just call CB increment. So as you can see, we've copied a shared pointer, and we increment amount of copies that this shared pointer has. Now let's implement the move constructor. Move constructor obviously takes an R value reference to some other shared pointer. It's no accept, and now we'll assign a resource with std exchange, wonderful function. Resource. The state of VS Code is really crazy. In CB, where is intelligence for that? That is crazy, bro. And since it's a move, there is no need to increment because we are moving the value. We are not copying, we are moving. There is no copy. Okay, now let's get to operators. They're a little more trickier. Let's make a copy operator first. Copy assignment operator, right? So I like the copy constructor. It takes a const reference. And now let's first make sure that we are not assigning the same thing, right? We are not assigning the same shared pointer, and then let's make sure also that we are not assigning the shared pointer, the different shared pointer, but with the same managed resource. So we must make sure that this is not equal to so the address of other, and we must make sure that the CB, our control block, is not equal to other control block. Now, when we know that, what happens here? Well, we know that there is some kind of different pointer, right? That will be now managed by our object. So we need to decrement the objects that manage current pointer. So we will do CB decrement. Now you might look at this. Well, actually, let's look what happens next, because that's really important. And now we will assign a resource, with other resource. So that's a copy, and CB with other CB. And at the end, if CB is not null, we just increment, because we just acquired a new shared pointer for that object. Now look at this, and if you're like, wait, is this legal? It is. That's true. Decrement might delete both resource and CB, but what does it delete really? It doesn't delete the variable pointer that is stored on a stack. It deletes some variable stored on a heap that this value on stack just points to, okay? So we can do this actually. This isn't use after deletion. This is assignment. This is a whole new assignment, okay? So it's okay. It looks suspicious. I thought about it for a second, okay, but it seems to be all right. Now let's make a move assignment operator. Shared pointer. What's going on? Other. Okay, let's go. Now we need to make sure that we are not moving, and that other is not the same shared pointer that we are trying to assign. And if it isn't, we basically do what we have done in a copy, but this time with an exchange operator. We decrement, and then we will do resource with assist exchange, resource CB equals exchange. yeah. Oh yeah, and we need to. Why doesn't it scream at me? I swear we are going to conduct this series in Visual Studio from the next episode, because Visual Studio Code is just a really, I won't say. Well, okay. It seems that we have completed operators and constructors, so now let's go to auxiliary functions. The first auxiliary functions is swap. And this is a really simple function. It takes in a reference to some other shared pointer, and we just go swap on components, right? So both on resource what's going on here? Okay, and we call swap on other CB. Oh, I see where the bug is. No, we just swap it. The next function that we're going to implement is get. Get returns a pointer to a resource. So we just return a resource. Now let's make a dereference operator. It returns the referenced resource, and the arrow operator will return a resource. So we'll just do return get. Frustrating as hell. Okay, this seems correct. Now, one last thing. We should actually probably make it a const here, just for the clarity. And one last thing we need to implement here is useCount. It's a simple function. It just returns, basically forwards the execution of useCount of control block, because control block is a private one, so we can't really access it from the outside, right? Okay, that's great. Now, the last function we're going to implement here is a shared pointer. Now, the last function we're going to implement here is a Destructor. And Destructor will decrement. So every time the shared pointer is destroyed, we just decrement the control block. Okay, oh, that's fairly simple too. CB decrement. Now, that's a working shared pointer. Now, let's implement make shared function. Now, make shared function, we have already created control block with the variable constructor. So now things will get simpler. This is the reason why we have written this constructor for shared pointer that takes in a control block. For this very reason. Because make shared, what we'll do is that we'll call this constructor on a newly created control block, and we'll just forward some arguments into the control block, into the new control block, and this way we'll create a new resource in control block. So let's do this. So as I said, it will be a friend function. So type name y. If it's type name t, there will be some shadowing. Let's make it a different type, but it will be just resolved by the compiler anyway. And it will also take a parameter pack. It's a friend, and we call it make shared, and it takes in an argument pack like that. Okay, so we have declared this, and now let's actually write this function outside. outside the class. Now, as I said, we will forward those arguments into the control block constructor, the variadic control block constructor. So let's make it here. Auto CB is equal to now shared pointer Y, scope resolution, control block. Oh yeah, a new std forward. And then let's return a shared pointer Y constructed with CB. Now, that's how make shared function works. In standard, it said that make shared function actually uses only one allocation. So it's not exactly as the standard says, but it's close enough. Now, I hope you liked this video. Give it a thumbs up, subscribe to my channel, and I will try to upload more videos with educational content. Next video, or maybe tackle weak pointers, we'll see. Okay, see you.